Hello everyone, this is Jyotsna. Welcome back to my YouTube channel. From this tutorial, we will start the different sessions on design patterns. So this is the very first session on design pattern. So let's start with some introduction to design patterns and then kinds of design patterns which we use, right? So design patterns are some proven solutions which are used in software development by developers, right? So these patterns provide some general solution guidelines and templates to help developers solve recurring design problems in their software applications. So throughout this series, we will explore various categories of design patterns from creational to structural, then behavioral design patterns, which provides unique approaches to solving specific challenges. So by understanding and applying these patterns, developers can enhance the code quality, promote consistency, and build more maintainable and scalable software systems. So let's dive in and discover the secret of crafting better software through the power of design patterns. So here you can see there are three different kinds of design patterns. GOF design patterns. GOF means Gang of Four design patterns. So why it is called as Gang of Four design pattern? Because these design patterns are introduced in a book, Design Pattern Element of Reusable Object-Oriented Software, and which is authored by four different people. So that's why those people are called as Gang of Four, and these design pattern are called as Gang of Four design pattern. There are actually 23 design patterns, which are then again categorized between creational design pattern, structural design pattern, and behavioral design pattern. So with creational design patterns, those design patterns deals with the process of object creation, while the structural design patterns deals with the composition of object structures, and behavioral design patterns deals with the process of communication, relationship, and responsibilities between objects. So here we will start with first with creational design patterns. So we will go through the five different types which comes under creational design patterns. So here we can see that these are the five different patterns which comes under creational design patterns. First one is singleton, then factory method, abstract factory, builder, and prototype. So we will start with singleton design patterns. So singleton design pattern, let's get to the introduction for it. So it is, as I said, it is a type of creational design pattern, and it is one of the very simple and widely used design pattern. And this design pattern lets you ensure that a class has only one instance while providing global access point to this instance, right? So this pattern involves a single class which is responsible to create an object while making sure that only single object gets created, right? That's why it is named as singleton. And this class provides a way to access its only object which can be accessed directly through and without need to instantiation of the object to the class, right? And let's go to the next slide. So here we'll see when to use the singleton design pattern. So when you want to ensure that a class has only one instance and provides a global point of access to that instance, that that time we can use the singleton design pattern. So there are different applications where we can use the singleton design patterns. So first one is resource management. So when you have a limited resources that needs to be shared among multiple parts of your application, such as database connection pool or logging services or thread pool, that time we can use the singleton design pattern. Then again, a configuration settings. So when you have a configuration settings that need to be accessed globally throughout your application, so such as database credentials or application settings or user preferences, that time you can use the singleton design pattern, right? So third one is caching. So here, when you need to cache expensive or to create object in memory, to improve the performance, such as frequently used data or objects that required heavy initialization, right? That time we can use the singleton design pattern. The next one is logging. As I said in the first application here only, when we want to log information from various part of your application to a single log file or stream, that time we can use the singleton design pattern. Then again, next is state management. So when you need to maintain a single state throughout your application, such as authentication or session management, that time also we can use this pattern. Then again, last one is hardware interface access. So when you need to interact with hardware components or external systems and you want to ensure that there is only one point of access to avoid the conflicts, that time we can use this design pattern. So these are some of the applications where we can use the singleton design pattern. There are many more actually, but I have mentioned some which are important ones. So let's see, problem statement means what problem we get when we don't use the singleton design pattern, how we can solve that using the singleton design pattern. So here, let's say that you are developing a system where you need to ensure that there is only one instance of a particular class throughout the entire application, and this class represents a crucial resource or service that you need to be globally accessible and shared among multiple components. So additionally, you want to ensure that the installation of this class is thread safe and efficient. So here in this example also you can see that if one of the resources already in use and some other person is coming to access that or object is coming to access that resources and he's saying, oh sorry, that I thought this room wasn't occupied, means here it can get conflicts, right? So it is already using by another resources and some other resources coming to get to access that particular object, right? So in this type of situations we can use the singleton design pattern. So how we can use that, let's see that. So as I said, we can design and implement the singleton pattern to achieve those problem statement or those objectives. So the singleton class should provide a global point of access to its instance, right? And any attempt to instantiate it more than once should result in obtaining a reference to that existing instance. So here the implementation will also handle concurrency issues in a multi-threaded environment to guarantee that the correct behavior of the singletons. So there are some steps which we need to follow while we use the singleton design patterns. These are these main four steps where when we create an object of singleton, we should follow. First is we need private static field to the class for storing the singleton's instance, and then the constructor should also be private. This is important. And then the method from which we are getting this singleton instance should be static, which is should be public static, right? And from client code from where we are creating or getting the instance of this singleton class, that should call this static method to get the singleton objects. So these are the main four steps we need for our singleton design pattern. So now let's see, there are different types of initialization we use for singleton. There are two different types. One is early initialization and then another is lazy initialization. So early initialization class is initialized whether it is to be used or not, right? Even if we want to use that singleton object or not, it will get initialized in the early initialization. But in the lazy initialization, class is initialized only when it is required. So with this we can save, it can save you from instantiation the class when you don't need it. Like generally lazy initialization is used when we create a singleton class. So this is what we are using. So let's see. So here is the class diagram, which is the generic class diagram for the singleton. So singleton will have the instance of singleton class and then method to get singleton, get instance or to get the instance of that singleton. and if this instance is null, create a new instance and return that instance. It will come in this get instance method. Okay, and then client can access this get instance method through this singleton class. So this is the class diagram. Next is advantages. So what are the different advantages of singleton class? So let's start with it. So first one is a control access to a singleton instance. Sorry, single instance, right? So here it ensures that a class has only one instance, providing a global point of access to that instance. This can be beneficial when you need to restrict the instantiation of a class to exactly one object, ensuring that all components of the system share the same instance. Then again, global access. So this is what we are giving the global access to all the resources through the singleton instance. So with this, it is allowing easy access to its methods and properties from any part of the code base. Then again, conserve resources, right? So here it can help conserve resources by preventing multiple instances of a class from being created unnecessarily, right? And especially in scenarios where the instantiation of the object is resource intensive. Then again, lazy initialization, as we saw that previously. Lazy initialization, which we use for the singleton instance creation. So here singleton instance can be lazily initialized, meaning the instance is created only when it is requested. Then again, thread safety. So singleton implementation can made be um, thread safe, ensuring that the multiple threads can safely access and use the singleton instance without encountering some conditions or any synchronization issue, right? Next is promote single responsibility principle. So by providing a single point of access to a particular resource or service, the singleton pattern can help ensure the single responsibility principle, right? And then simplified global state management. So it simplify the management of global state without an application by encapsulating with single object, right? Making it easier to reason about and maintain. Then again, facilitate testing. So in case where you need to replace a singleton instance with a mock object for testing purpose, it's relatively straightforward to do so. Like so, the access to the point of singleton is typically well defined. So these are some of the advantages of singleton. Then again, singleton comes with some disadvantages also. The first one is violates the single responsibility principle because the pattern solves two problems at the same time, right? And then again, global state. So the singleton introduces a global state into an application, which can make it harder to reason about maintenance, right? And changes to the singleton state can affect the behavior of any part of the system that it relies on, and it leads to unexpected side effects or bugs. Then concurrency issues. So implementing a thread safe singleton can be challenging because, especially in multi-threading environment, if not properly synchronized, concurrent access to the singleton instance can lead to deadlocks or any other concurrency issues. Then again, hidden dependencies. So classes that depends on singleton are tightly coupled to it, and which can make it harder to refactor or replace the singleton. So here, um, so when we use the hidden dependency, this can increase the complexity of the code base and hinder the flexibility. Then again, the potential for memory leaks. So it, if not implemented, if we do not implement the singleton design correctly, that time it can persist for some lifetime of the applications for the memory leaks, and potentially leading to memory leak if resources are not properly released when no longer needed. And the last one is misuse of singleton pattern. So this is one of the significant disadvantages actually, because there might be a potential for misuse of using the singleton design pattern. So sometimes what happens, developers may be tempted to use the singleton pattern in situation where it is not applicable, and that will lead to overly complex design and unnecessary constraints on system architecture. So these are some of the disadvantages. Next is relationship with the other patterns. So singleton design patterns have some relationship with other design patterns. Some of them are factory method, where the singleton pattern can be implemented using a factory method pattern, and factory method pattern can ensure that only one instance of singleton is created and returned to clients. So we can use the singleton with factory method also. So we can also use the singleton with other, like abstract factory. In some cases, this factory method might create singleton instances, and abstract factory can be used to create families of related or dependable objects. These types of factories, patterns, we can see in our next videos, coming videos. So we will get more idea about it. And here, if you see, the abstract factory can be used to create families of related or dependable objects, and if one of those object needs to be singleton, then abstract factory can manage the creation of it, right? And with the builder pattern, this pattern can work with a singleton pattern by constructing complex objects that includes references to singleton instances, and the builder can then enforce that only one instance of a singleton is used within the constructed objects. Then again, decorator design pattern. Here also, this pattern can wrap a singleton instance with additional behavior. So these are some of the patterns which are which have the relationship with the singleton design pattern. So let's see one of the example for this. I already have my Visual Studio open. So let's create one simple program with the singleton. I have created one console application here in C Sharp. This is the default program class we have. Now let's create one singleton class where we want to add or create the singleton instance. Let's give the name singleton, or only singleton you can give, right? So as I said here, we have four different steps to implement our singleton design pattern, right? So let's start with that. First, start to and create one private static field here. Means we are creating here static instance, and it should be private as we mentioned. So it is giving me some intelligence here. Let's say that we have this private static singleton instance. Now I want to initialize that instance here. Now create new instance here only, new singleton. So this is a class name. This is how we create a instance of a class. So class name, instance name, and then new keyword is used to create an instance. So these are some basics of programming languages, right? So then again, in the next step, second step, we need to have the private constructor, and how we create the constructor, right? Let's see. Constructor. So to create a constructor, constructor will always have same name as the class name, right? So constructor is a method which always have same name as the class name. So this is our private constructor. We don't have to initialize anything in it because we only need to make that constructor as private. Then again, what we have, we need to create one method which is a public static method to get a singleton instance. Let's do that. Public static. So this is what static method to get instance, right? So it will be public static get instance. I will just give the name of that instance as a get instance, and it should be of type singleton, right? And here, because we are returning the instance of singleton class, so I am giving this type as a singleton. And now here I want to return this instance here. So let's return it, right? So we did all three steps here, right? We created a one static private static member. We have our constructor as private. We have created one method to get the or return the instance. Now let's go to our program. Yeah. Now before that, what we do, we define one new method where we want to get some value, get and set some value, right? So first I will use one, I will create one method where I'm setting some value. So I will set value of name, and here so I will create one very private variable with name here, so that we can use that here, private name, right? So now I want to initialize this name to this private string, right? Name. So name is equal to name. So what it will do, so now we are not returning anything, right? So we just make this method as void here. So this method will set this our name property here, right? Now I want to have one set method also to set the value for this name. So I will just get this one and return name. So I have just for the sake of our problem, I am taking these two methods here. Now let's go to our program.cs. So here now I want to create different instances, right? And actually it will get the same instance for me. Let's see how we can implement our singleton here. Now from here we need to call the um, give the call to the singleton class to get the instance of it, right? Call to get the instance of singleton class. So here first what I will do, I will create the object of singleton. Singleton, I can say first instance. And now if we see our this method is static, so we cannot use cannot access this method with object creation. We can access that with class name only. So any method which is declared with static, we can access that using class name only. So here I will use that class name dot get instance, you can see here. So this what this will do, it will get the instance of this class here. And then again what I want to do, I want to set some value for this. So I want to use get some, this, okay. So I want to access this method also, right? So I can access that using this instance of singleton class which I have just created. So I'll just do that and set value, where I will set some value for this like my name only, right? Now what I did, I have created instance of a class and set some value for this name property, right? Now let's create another instance of a class, second instance. And then I want to get set, I have already set the value, right? I want to get the value now. So using second instance of a class, I am trying to get the value. So what is the name of that? So I will just say that get value here, so that those names will be somewhat. Right. So this now what I did with first instance, I have set the value, and from the second instance, I'm trying to get the value for that name property. So let's see what it gives. I will just mark the breakpoint here. Uh, After this, I need to, what I will do, I will just console it so that we can see the which value we have taken, right? Then console dot write line. Okay, let's start it. Okay, so now we are here. We are creating first instance of this class. I will do F11. So that time it will go to the method of this get instance method because we have called that. And then it will try to return this instance which will already have the instance of this singleton class, right? So name now currently it is null and the instance is singleton instance, right? Now if we see here we have this singleton instance. Then again we need to go and set the value for this name. Now I have already given the value here my name, and then it will go and inside the name and it will set that name property here. Now let's see and how it will create the second instance. So we already created first instance, so with singleton it should get the first instance only here in the single this second instance. Let's see how it happens. Now again it is going to the get instance method and return the instance. So here it is the get instance method, right? Now if you see, this instance have the singleton instance, and whatever the set value it was previously set in the first instance, it is there, right? Now we can just get the value and return this value here. And if you see now, this value is written here. So what they done, so they created first instance and set some value to the property, and then again this the first instance only given here for the second. So a single instance is used by these two, right? So here we are setting the value and here we are getting the same value, right? And so how this is how we can do with the singleton programming, right? There are very different programs are there, like logging to the same logger file and getting the same data from the same logger file and all. So this is just a very simple example I wanted to give for the understanding. So main thing we need to do is like static instance. This is the main part while we using the singleton design pattern. Then private constructor and then static method to get the instance. And from our client code, we need to um, access the get the instance. We need to call this get instance method or whatever the method you give to where you are returning out your class instance, right? That way we can have the only a single copy of the instance throughout the class, right? So this was a very basic example for it. I think we are done with singleton now. So most of the parts I have covered here. Next time we will see the factory method pattern, right, in our next video. Till then, thank you so much for watching the video.